Now if V and W are vectors, as we've seen, V cross W has a magnitude that's equal to the area of this parallelogram formed by or defined by V and W. Let's take our cross product vector V cross W, which has a magnitude equal to the area of this parallelogram and is perpendicular to both the W and the V vectors. Now this looks like it's vertically downward. That's not going to be something that we generally assume. It's just the way we happen to draw this one. This plane could be tilted at any angle. Now let's take a third vector U. And U looks like it kind of goes down and to the right, and it projects back to the V cross W vector at a perpendicular, forming the projection of U onto V cross W. So this is a projection onto V cross W of the vector U. This vector is going to turn out to be an altitude of a three-dimensional figure, and let's sketch the sides of that figure. If we move over parallel to the W vector from the tip of the U vector until we reach a point where a vector perpendicular to the or parallel to the U vector from the tip of the W vector meets this line, and then move back parallel to the W vector, and then down parallel along this direction. We get the sides of a three-dimensional figure. The top is the parallelogram defined by V and W, and these edges are parallel to U, this edge is parallel to W, this edge is parallel to V. We want to consider the area of this solid, and without going into a lot of detail about why it's so, it's fairly straightforward. The distance between this plane and the plane formed by the bottom of this figure is just the length of this projection. And it follows that the volume of the figure is the area of the base multiplied by the altitude of the figure, and that is equal to the magnitude of V cross W, which is the area of the base, multiplied by the magnitude of the vector projection, the projection onto V cross W of the vector U. This, in turn, has a magnitude that's equal to the magnitude of V cross W, and I shouldn't have put the absolute value signs around that. We're looking at how do we calculate the projection onto V cross W of the vector U. Well, we project U onto V cross W by multiplying or doing the dot product of U with V dot W, dividing by the magnitude of V dot W, and that's going to be the altitude of our figure. So it's going to be the magnitude of V cross W multiplied by the magnitude of this projection. The magnitude of this projection is just U dot V cross W divided by the magnitude of V cross W. Well, the magnitude of V cross W is here and here. Let's use the magnitude symbols. And when we multiply this out, we find that the magnitude of V cross W multiplies out, and the volume is just U dot V cross W. Now, there's one more thing I need to do here, and I need absolute value signs around this. Since this is a magnitude, that'll make this into a magnitude, but it's the magnitude of this dot product, and that magnitude represents the volume of this three-dimensional figure.